Alison, for the opportunity, and hello, everyone. Yes, I'll be discussing SkyBugs. Like Alison said, using IPM and drone and beneficial insect technology to get a kind of a combination solution for farmers in Southern Africa. So I'm just gonna take a step back and just focus again a bit on IPM, integrated pest management, and kind of see where we started with this project, and taking into account the kind of two birds with one stone, where we wanted to solve a kind of the physical aspect and the biological leg of integrated pest management into a combined solution. Um, and then how SkyBugs were formed. It is actually two companies. Um, I work for FieldBugs, who specializes in beneficial insects, and Aerobotics, who's a well-renowned international company, uses drones. And one aspect of their company is using drones for survey work, multispectral and thermal imagery, and then processing this data. And then with this data can use actionable decisions on the farm for bigger and better quality yields for from wine to other valuable tree crops in Southern Africa. And also, robotics has got a great network in the States and Portugal and Australia as well. And then jumping on to SkyBugs. So we've combined these two companies. Aerobotics is, like I mentioned, the drone network, and the FieldBugs is beneficial insects. And then I've quickly just have a quick video just to show, kind of explain exactly how this whole process would work in the device. This will just kind of give you some sort of perspective on how it works. Okay, yes, and then just to kind of go back into the reason for using a drone to release beneficial insects. The one big one, especially in challenging times in agriculture in Africa and around the globe, is cost. Cost is the first thing on most growers' mind, and the traditional way of putting out insects, beneficial insects in the field, is these kind of tubes with a little hole, especially for mealybug predators. Is a little pupa mummified mealybug in an insectary. You'll hang these in the field, and a wasp would fly out and find a mealybug via a female mealybug via pheromone, and then actually parasitize and get control that way. But for cost, these little tubes quite expensive, biodegradable. To actually pack this, label this, and actually distribute this to the farms is quite expensive. So with the drone from the insectary, we can get a bulk product, load the drone, and fly straight away. So big cost there on packaging and labeling and so on. And again, the other two speakers also touched on the uniformity. So the drone flies at a constant speed, constant height. The device opens and releases in a consistent speed, and that would give you a very good uniform spread of the beneficials over a block. And then time efficiency, another thing directly related to cost as well. You get farms, 100 hectares, 200 acres plus, to hang these out in the field, especially if it's a difficult terrain, can take 3 or 4 laborers, can take up to 2 or 3 days. If it's over 150 hectare. With the drone, we can fly about 300 hectares a day, possibly more if the terrain is a bit flatter, or pretty flat. So we can do up to 200 hectares a day. So that's quite a big saving cost. And then data. A few of the other speakers has also talked around the importance for IPM of data collection. And Aerobotics, with their drone technology, has also got an excellent scouting app. So you can, once you release the insects, go back in a few weeks, scout with a phone, take photos. It drops a GPS location, collect data, and actually see these beneficial insects that you've released via drone, if they're actually doing their work and how effective they are in controlling the pest in question. And again, labor, how SkyBugs we operate is we will actually send these little tubes to the traditional way to the grower. Their local labor would then put out the insects, and we really don't have control over the application method. With the drone, it's in our hands. We are in control of the whole process, and we can then be sure that it's up to our standards. And then an interesting one is insects near hatch. Again, for the traditional tubes, you would have to get insects that's maybe 5 or 6 days from hatching. Again, it needs to go to a repackaging facility, get put in a little tube, then travel with courier. Most farms are in rural areas, so the insects need to sit there maybe in an office for a day and then get put out in the field, where we can communicate with our insectary and say, listen, for these mealybug predators especially, we want the closest to hatch pupa available for the drone application. We then get them within the next 2 days, load the drone, and ready to fly. And then just a little background on the specific beneficial insects we have started with SkyBugs. The ones that are not live insects, these are all pupa, mummified, or egg form insects. So 2 Anagyrus perminutus, 4 mealybug actually parasitize, and the lacewing is kind of a generalist egg form insect that we also can put in the drone for kind of a cocktail, which is, like I mentioned, a generalist. They are not species specific. They will actually control most soft body insects. And then just a little bit of background on these little wasps. For mealybug control, they will, let's say, get released via the drone. They would then hatch within a few days, find female mealybug in the field, lay an egg inside. Within another 4 to 5, 6 days, depending on temperature, a new wasp would hatch, and this process would continue. And that's kind of the method of controlling mealybug. And then just a little bit, I did mention the drone flies at a consistent speed and height, and then in this zigzag pattern would then slowly release beneficial insects over a specific orchard or vineyard. And then these are kind of, for mealybug specifically, the products that we'd have. We have kind of a standard 1,000 Anagyrus, 10,000 perminutus per hectare. So in this drone, it's got little cells. We would then load, each cell is calibrated to a hectare at that speed of 30 meters above the block and 10 meters per second. So we'll load 2 of these, and that's exactly a hectare. So we can very accurately release insects per hectare form. And then on product 2, these first 2 works very well for crops like table grapes and citrus and apples. And product 3, a little lower dosage, that works very well for wine crops, for wine vineyards. And then I'll come a bit later on what's in the pipeline for SkyBugs. And these are just the varieties of crops that have pests that we have solutions for at SkyBugs. Wine, table grapes, pome fruit, stone fruit, max citrus, and avos. And yes, in the Western Cape in South Africa, I think 80% of the fruit gets exported. So like some of the other speakers mentioned, chemical residue is getting stricter and stricter for export. So very important for growers in globally to take chemical residue serious. And then we also offer a great service with this drone application in forms of with that scout on the phone, also a post-flight report. So exactly what was released, how many flights it took us, how many hectares we flew, and a little bit extra information on that day that you can then save in your archives for the next season. See what we did last season. Are we going to adjust that somehow to the data we collect this year? And then we often get a lot of questions on netting. A lot of fruit in Southern Africa is under netting. If that's going to have an effect on the insects. For our current mealybug applicator, these pupa form insects will fall on the net. They would either then, with a bit of wind and movement, will fall through and hatch, or they will then hatch outside the net, and the holes in the net are small enough so they can get in and still control pests underneath. And we did do some trials for this method, just to a proof of concept. We put down sticky film, flew over a zigzag pattern as we do normally, and then see what we collect. Again, like one of the other speakers mentioned, that drift is quite a bit of a factor and something to consider, which was quite tricky to get an accurate release. But you can, with a buffer, fly the drone, and we could then get a good, we could observe quite a bit of product on the sticky film. We did the same on a tennis court. We put fluorescent dye on the pupa, flew over a tennis court in that zigzag pattern, and actually see on the floor what we could observe. And we did get some decent results. Again, I have to mention that this is quite a tough distribution, tough to test for distribution with this method. The best way to prove concept is actually to scout in the field post-flight and see the rate of parasitism. Just to focus a bit, or just mention again, I think Aerobotics' infield app again has been extremely helpful in taking the insects that's been released and observing and collecting data on the ground, and to actually put that into the report for our the clients, and just make sure that what we've released, we can then maybe adjust the second release, maybe up or lower the dosage, or get the timing correct, because that is, in the end, beneficial insect releases. The timing and dosage is crucial to get any sort of control. And this is just an example of the scouting and post-flight report we did. These yellow points are all the spots where this is a second oldest vineyard in South Africa, vergelegen, quite a big 120 plus hectare farm. We flew this 5 times this season, released I think 500 Anagyrus pupa. Then 2 weeks post each flight, we went and scouted and see what we could find. For this actual farm, it was a very proactive approach. So we didn't wait to see any sort of pest. We just released just before the warmest time of the season, and what the males in the traps gave us. And we then put this all into a report, and could actually see that what we released did help with control. Next in the pipeline for us is to move into live insect release. We are currently working on a device on a bigger drone to relieve predatory mites that would then help us control insects or pests on a bigger range, more crops, especially things like two-spotted spider mites, a big issue in South Africa, along with thrips, aphids, and that is something we are working on this kind of winter season to to have ready for September when our growing season starts. Yes, thank you. That is, in a nutshell, SkyBugs. Yeah, if you guys have any questions.
Fantastic. I'm sure people have
you can go.
questions. No problem there.
Yes.
I have lots of questions myself, and I see questions already coming in.
Yes.
A couple of quick questions. I'm going to fire them at you. The
Yes.
height of the drone as it flies over, I think you had 30 meters. Is that correct?
Yes.
If I read it
Yes.
correctly. So that's quite high.
Yes.
Obviously, that's the optimum height, or does it? What's the difference from maybe flying lower? I mean, we heard that drones can fly quite low at the moment.
Again, for flying the drone, that's a good question, Alison. Thanks. Yes, so we can fly a bit lower. It's just for a lot of crops, South African, a lot of the farms are on pretty undulating hills. So to fly at that height, the pupa, we also did the testing that they wouldn't actually, the mortality rate doesn't go higher if you fly a bit higher. So we also pack the drone with 20, because of the kind of costing we save with the little tubes. We put 20% extra product than what, let's say it's 1,000, we'd put 1,200 pupa in. For that one that falls on the road and the tractor goes over, we compensate for that. So in terms of mortality, we cover our bases in that way. With the live insects, we'll obviously fly a bit lower because it will be live mites we will release. We are currently doing testing to get the calibration correct to have an optimal height of flying for the mites to actually hit their target. For the mites, you actually have to release a lot more accurate than the predatory wasps or the wasps that parasitize, as they have wings and they will, with pheromone, find female mealybug. But with the mites, you actually have to release straight on the canopy row, and we will have to fly a bit lower for the live application.
Okay, excellent. I've got a question here. Do you have any difficulties with supplying enough insects for all your growers? If so, do you try to use a more targeted release?
A good question. I have to say the insectaries in where we get our insects from, it is a constant challenge because it is a live culture you are busy working with, and there can be complications with that. But we have kind of good relationship with a few insectaries where we kind of, they have their logistics in place to actually, at the right times of the season, to have enough supply to actually, for us to service most of our clients.
So thanks for that. And here's a question from me. You talked about maybe the way of seeing how, I guess, the outcomes of using this. You talked about the rate of parasitism post-flight. And I guess I was interested to know what you've found is the rate of parasitism when you've gone back. So
yes, that's a good question. That's a good question, yes. So for a lot of these releases, they are proactive. So the best kind of time, we always say, to start with a bigger chunk of your IPM being biology, is to start before you have problems. And then it's a bit easier with, again, the mealybug kind of predators. You can actually observe that little hole that the wasp has flown out of. And we've actually had some really good results in that specific instance with the wine estate. They just did 5 releases proactively and didn't really have pressures go up and down the season. Other farmers where we did fly in apples, we did see excellent rate of parasitism. Again, it's tough to do direct correlations. There's also in some areas very good natural predators that actually occur as well. But what I can say is we've had very good parasitized mealybug, especially where the chemical kind of program for the season has been low, where the insects have actually gone in and not kind of kept their numbers up through the warm times of the season. And a big thing for mealybug and the mites is also ant control. That is kind of the basics of mealybug IPMs. These ants will actually protect mealybug, that honey dough that they secrete. They would actually protect that food and stop the wasps from coming in. So that's also something that plays a big role.
Thanks, Ruan. Good answer. And here's another question. Do you have any data on the percentage of marketable yield increase after application of the SkyBugs? Do you have some examples?
So this is our second season. We can actually, so that would all say in pack house at harvest time. That is kind of our rate of how we measure rate of success. Very difficult to do it in the field. A lot of things play a role. But we do have some data on where we did flights and released insects at the end of the day in the pack house. I don't have that direct data, but I can find that.
Yeah, that's great. No, thanks. Good answer. And I've got a question about the cost of this. So obviously a vineyard sometimes, I mean, sometimes they do spend a little bit more money than other growers, or producers. What is it costly to do this? I mean, you talked about the cost benefits before compared to putting out the little traps, I guess, but how costly is this to do?
Yes, so that's a good question. Yes, again, the cost, like some of the other speakers also mentioned, there's quite a bit of red tape, and it's the same in South Africa to actually acquire a drone license. You need a license and a permit to fly commercially, and aerobotics actually do not employ as well their own pilots. They build up a network of pilots where they have clients and then use these guys. That's the best way to scale. So the pilot has got a fixed cost, and then the beneficial insects are a bit cheaper, not in bulk. So we're looking at, for the wine dosage, between $50, rand, $50, and it can go up to, I think, 150 per hectare, if I'm not mistaken. I'm just in my head calculating it from rand, but that looks correct. Yes. And that includes your service. Sorry, that includes that's the flights, the post-flight reporting, the scouting. That's all included in that application and service.
Yeah, yes. Excellent. Thanks, Ruan. And I guess as I mean, you're relatively new, and this is actually, it's quite hard to find good examples, to be honest. When I was looking for speakers, and I saw, it's quite exciting, but it's quite a developing area as well. So as you get more, more experience and more projects and develop the expertise, I guess those costs will come down. So it's exciting to see. So very, very interesting. And I think, Brett, did you have your hand up before to speak? I mean, you can unmute yourself and introduce yourself if you want and say a few quick words. Brett, can you hear? There we go. Yeah,
thank you. Thank you for adding me as a panelist. Yeah. Just to introduce myself, I'm Brett Agiotis. I work with Ruan. I'm from Aerobotics. We're the drone tech company that have partnered with SkyBugs to form SkyBugs. There was a question on improved yields and sort of costs or examples of that. I think just to add, this is not only like a reactive approach to pest control, but also a proactive approach. So you preventing pest pressure and losses if it comes to harvest time. A lot of growers are having issues with when they do harvest, and especially when you export the fruit and nuts. If that container suddenly is inspected at the border or shipped, if any pest is actually picked up in that container, then the entire container could be rejected. So it's really vital that the pest pressure is managed during the farming season and while it's harvested. So solutions like SkyBugs can really help with that, instead of a whole container being rejected and you lose millions of rand in hard-earned work, for the season. So I think it's stuff like that that can really help with the yield output. But yeah, we've seen with the clients we've worked with that there's been a huge improvement just in preventing that risk from happening, instead of it coming time and then it happens, and what do you do with that export?